Okay? Now, hey, those were the horizontals. So let's figure out how to find the vertical ones now. All right? We'll put those same graphs back up there that we had, those three earlier. And there we go. Now, those are the same graphs where we find the horizontal. How do you find the vertical asymptote? Now, remember this. What can you never divide by? You can never divide by 0. So the way you find the vertical asymptote is to go to the equation, and if the denominator is 0, if this is 0, what happens to this whole thing? It's not possible to divide. So basically, to find the vertical asymptote, I set it equal to 0. X plus 1 equals 0. Well, I'll subtract 1 from each side. Hey, the vertical asymptote occurs at x equals -1. X equals -1 right there. -1. All right? Let's look at this problem right here. It's a little easier, I think, first off. So, once again, how do I find the vertical asymptote? It only occurs when the denominator is equal to 0. So, set the 2x minus 3 equal to 0. Add 3 to each side. Divide by 2, so x is at 3/2. The vertical asymptote occurs at x equals 3/2 on this equation. Well, Coach Tony, why did you skip the middle one for a second? Well, glad you asked that question. Look right here. In order to find the denominator, when it equals to 0, guess what we have to do? Yes, that's right. I know what you're thinking. We have to do, like we spent that whole week learning how to read, teaching how to factor, because you have to factor this. Now, question for you though. If this factors to, factors 4 are 4 and 1 and 2 and 2, but 4 and 1 subtract to make 3. 4 is larger, has to be negative. That one's positive. So if I set each of these equal to 0, remember, if this parentheses is 0, the whole thing's 0. Or if this parentheses is 0, the whole thing's 0. So 0 equals x minus 4, or 0 equals x plus 1, meaning that at 4 and -1 we have vertical asymptotes. But wait a minute, Coach Stoney. I'm looking at this right here. I only see 1 popping up here at positive 4, when 4 is 4. That's right. Because we have something special about this one. This one's called a hole. And technically there should be a little mark right there that shows up. But in your graphing calculators, because it's so tiny, it's so small, and gets exactly close to that point, it doesn't show up. Your graphing calculators will never show, they'll show that blue line like what it was before I put that little mark in there. I had to manually add that little mark to it. The calculators do not show it. Here's why this is a hole and not an asymptote at -1. Did I factor this top one? I did not. Let's set this top one equal to 0 for a second. If I factor this, what's common? Each of these are 3, and that would be x squared minus 1. It would factor to 3 times x minus 1 over x plus 1. This has an x plus 1. Guess what would happen to these two? This factors to that and that. Guess what happens to the x plus 1s? They would cancel out. So meaning as you would normally have an asymptote as you approach it, you're also approaching it by the same value, very parallel. That's why there's not an asymptote and there's a hole right here. The holes occur when you have the same value in the numerator as the denominator. That's why this is not an asymptote, because it's a hole. Asymptotes approach infinity. It keeps going and going. All right? Notice, as we got to 4, it's going to get to infinity here and infinity up there. But as we get closer to -1, we're approaching -1 from the same direction on both of these. That's why it doesn't make another asymptote right there. That one created a hole. That's very important. So we're going to learn about, we learned about horizontal asymptotes, vertical asymptotes, and holes. Let's look at another one of these vertical asymptotes. This is the problem we had a while ago, right? Remember this? This is the graph. Do we see a vertical asymptote here? We do not see a vertical asymptote here. Why? Why is there no vertical asymptote even though we have an x in the denominator? Well, how do you find the vertical asymptote? You set the denominator equal to 0. First off, I set that up to do the horizontal one, which is a 0 over 3. But to find the vertical one, is 3x squared plus 1 equals 0, right? Find the vertical, looking at the denominator. I would minus 1 from each side. And then I would divide by 3. And when I square root it, can I square root negative 3? No. That gets an imaginary answer. Hence, that's why there is no vertical asymptote. There is no value that I can put in this equation that will give me 0 in the denominator. Hence, there is no vertical asymptote. Not going to happen very often. Usually it happens when there's an x squared with a plus value here, because you would have to be able to get an imaginary answer for that to work. And imaginary numbers don't graph very well. Be real honest, can you see your imaginary friend? You can't see your imaginary number. Alright? So that one was unique. There's not possible, so there's no vertical asymptote. So let's look at this next one. Ooh. Let's go ahead and look at the graph. Now notice, the horizontal would be 2 over 1. We did that earlier. But to find the vertical, set the denominator equal to 0. As I set this equal to 0, factor it. It's x plus 1 and x what? Minus 1. Meaning, x minus 1 or x plus 1 equals 0. So you have a vertical asymptote at 1 and negative 1. Alright? So, and here we go. Now I showed all the vertical asymptotes right there. Here we go, right there. Notice, that's why this one has 2. Because the denominator has 2 places that it can equal 0. So you have 2 vertical asymptotes. Look at it. We have it approaching infinities there. And also down here in the negative end. Alright? And the horizontal asymptote at 2. Right? There are no values that will give you answers from 0 to 2. Well, you can have 0 as an answer, but not anything above 0 or to 2. Okay? Woo! So to find the vertical asymptote, you set the denominator equal to 0. That's what you have to do. Alright? There we go. Alright, go ahead and stop it a second.
Oh, sorry.
Stop it.